In our last class, I have shown you a derivation, right? And I told you that this math will be similar to that. Let's see the math. In a 33 kilovolt overhead line, remember, this is the line to line voltage, okay? Whatever voltage they will give in line to line voltage. But you have to find the line to neutral voltage, okay? That is phase voltage. You have to find the phase voltage first. Whatever voltage they are going to give you, that is the line to line voltage. So you have to divide by √3 so that you can find the voltage of one phase, that means phase to ground, okay? Line to ground or phase to ground or phase voltage you have to find. There are 3 units in the string of insulators. 3টা insulator থাকবে. There are 3 insulators. Is the capacitance between each insulator pin and earth. Remember, see the word. This is very important. Capacitance between each insulator pin and earth, right? That means capacitance between insulator pin and earth. Which one is insulator pin? Insulator pin is this, right? And earth is this. So between insulator pin and earth, that is what? That is actually shunt capacitance. Shunt is 11% of self capacitance. Obviously, this is shunt, this is self. So your shunt, or I can say C1, your C1 is equal to 11% of self capacitance. Self capacitance means C. So C1 is equal to 11% of C. What is this 11%? Can we write 0.11?
Yes.
0.11. So that is actually your K, the value of K, right? So finding out the K is one of the most important part in your math. Find the distribution over the voltage. Distribution means V1, V2, V3, all those voltage over 3 insulator and string efficiency. So you have to find out V1, V2, V3 and efficiency. That's it. So let's clear everything. So this is the figure. So 1, 2, 3, C, C, C. This is C1, C1, C1. That means KC, KC, KC. Here the value is I3, I2, I1, I3, I2, I1. So total voltage is V. What is the value of V? Value of V is equal to 33 divided by √3. Can? Why? Because this value is line voltage. That means line to line. You have to find the phase voltage. That means the one phase voltage. তোমাকে এই লাইন ভোল্টেজ থেকে তোমাকে ফেজ ভোল্টেজ বের করতে হবে। এই লাইন ভোল্টেজ থেকে ফেজ ভোল্টেজ বের করার জন্য ইউ হ্যাভ টু ডিভাইড ইট বাই √3। তোমাকে √3 দিয়ে ভাগ করতে হবে। তাহলে তুমি যে ভোল্টেজটা পাবা সেটা হবে ফেজ ভ্যালু। ফেজ ভ্যালু মিন্স in between line to ground. Okay, normally the voltages are given, that is line to line. That means if you have 3 lines, one line, another line here, the voltage is in between line to line. That means 33 kilovolt. Line থেকে লাইনের মধ্যে ভোল্টেজ দেওয়া আছে, but you have to find out the phase value. That's why divide by √3. 19.05 kV. Now here at junction A, you have 2 current, I1 and I1, and you have 1 current entering, that is I2. So write I2 is equal to I1 plus I1. I2 is equal to V2 omega C. V2 omega C. What about the I1? V1 omega C. What about the small I1? V1 omega Kc. Why V1? Because this voltage is also this voltage. Okay, so V2 omega C, V1 omega C, V1 omega Kc. Here omega C, omega C, omega C, omega C, omega C, omega C is gone. What you are left with? You are left with V2, V1, V1K. So you can write V2, V1, 1 plus K. If you take V1 common, K, the value of K is equal to 0.11, because that we have already seen that. So V1 1 plus 0.11 So your formula is this one. V2 is equal to 1.11 into V1. Okay, understood? That is one formula, the formula number 1. Okay. Now, at junction B, you have one current coming, I3, equal to I2 plus I2, right? So again, I3 is equal to V3 omega C. I2 is equal to V2 omega C, right? The important part is this one. This I2 will be V1 plus V2. Why? Because this value, this voltage, in this capacitor, the voltage is V2. In this capacitor, the voltage is V1, V3. In this capacitor, the voltage was V1. But in this capacitor, the voltage is what? V2 plus V3, right? Have you understood? In this capacitor, the voltage is V1 plus V2. Why? Because see this one. If you take a multimeter and if you put the red pin here and put the black pin here, so you are supposed to find out the voltage, right? But what voltage you are measuring? Putting the black pin here or putting the black pin here are same, right? So what you are measuring in between? V2 plus V3? Because in between you have V2 and V3, right? These and these. Understood?
Yes, sir.
Okay. So V2 plus V3. So this one will be V2 omega C. This one will be V1 omega C. This one will be, oh, this one, next one actually.
I
This one. This one will be V1 plus V2 K omega C. So again, omega C, omega C, omega C, omega C, omega C, omega C are gone. You are left with V3, V2, V1 plus V2 K. So if you take V2 plus V1K plus V2K, you can put the value of V2 from here. Put it here. V2 is equal to 1.11 V1. V1 is V1. V2 is equal to 1.11 V1. K is equal to 0.11. From there, if you add all of those and if you simplify all of those, you will find V3 is equal to 1.342 V2, right?
Yes, sir.
Okay. Now, V is equal to V1, V2, V3. V1 is V1, V2 is 1.11 V1, V3 is 1.342 V1, right? So if I add all of those, what is the result? 1, 1.11, 1.342, 3.452 V1, right? Now this is V1. We already know the value of V. We already know the value of V. What is that?
90.05.
19.05. So if I take that and if I divide, so your V1 equal to 19.05 divided by 3.452. The value is 5.52. Okay, your value is 5.52. So if you put this value here, you will find the value of V2. If you put this value here, you'll find the value of V3. Understand?
Yes, sir.
Okay, wait a second. Please wait a second.
Okay. Okay. 2.452. Let's 3 for you.
Okay, now see, if you put the value of V1 in these two equations, you will get V2 and V3, right?
Sir,
Yeah.
and V2 and V3 adding is 2.452.
I didn't get it. Which one? This one, right? 2.452.
Yeah,
See,
two
no. You made a mistake. V2 and V3, they add up. You have a V1 as well. Here you have one V1, 1.11 V1, 1.342 V1. So if you add all of those, you get 3.452 V1. Understood? Hello?
Yes, sir.
Yes, sir.
You understood?
Yes, sir.
One plus
Yes,
one.
sir.
If
We have
V1 is only one.
You have one here. Okay, 1 plus
Ha,
1.11.
yes.
Okay.
Yes, sir.
Okay?
Yes.
Okay. Now,
we
let's...
already we take one.
Okay. Now see, your value is 5.52 kilovolt. Your V2 is equal to 6.13 kilovolt. Your V3 is equal to 7.4 kilovolt, right? Now the string efficiency, the formula of string efficiency is equal to voltage across string, that means total voltage, that is V, number of insulators, and V3. Number of insulators means 3, obviously that's why it is V3. Voltage across, that means the total V. So your actual formula is V 3 into V3, right?
Yes,
That's
sir.
the formula. So 19.05, that is your V, 3 is 3, and 7.4 is this one. So your efficiency is 85.8%. That is not good. Okay? That is not good. Understand?
Yes.
Okay, that will be harmful for your string. So we need to improve it. We need to improve it. Okay, let's see another math. Okay, one more thing.
Sir, how we can improve?
Okay. We have one very big topic. See, improving the string efficiency. We haven't done it yet. We will do it after the math. Okay. Now here, one important thing. You can apply this KCL thing every time, or you can memorize the formula. What is the formula?
Okay.
This one, right? Like this formula. Why? Yeah, here. V1 is V1, V2 is equal to 1 plus K V1, V3 is equal to 1 plus 3K plus K square V1. You can memorize the formula. But I do not suggest you to memorize, but you can memorize. If you do not like to do it every time, you can memorize the formula and you can put the formula there, okay? But the problem will be when you have 4 insulators, that time you will be in problem. That time you have to apply the KCL again. So I suggest you to do the KCL, but if you do not do the KCL and if you write the formula from memory, you will get the full mark, okay? You do not have to do all of these things every time. No, you do not have to do it. You can actually write the formula and find the value. Write the formula, find the value. You can do that. Understood?
Yes, sir.
Okay. Now the next math. A 3-phase transmission line is being supported by a 3-disc insulator. The potential across top unit, that means near to the tower, that is V1. Near to the tower means what? Top means what?
P3, sir.
No.
P-
Near to tower. Here, 1, to
That V1. V1.
which one is near to tower? V1
V1,
is near to tower. Which one is near to conductor? V3 is near to conductor.
V.
So top unit means V1, and the middle unit means V2. 11 kilovolt and 8 kilovolt respectively. That means V1 is 8, V2 is 11, right? Kilovolt, okay? Calculate the ratio of capacitance between pin and earth to the self capacitance. Pin and earth. Ratio. Since they said ratio means
Okay.
you have a capacitor here, you have a capacitor here. But which one is C1, which one is C? Let's see. The upper one is what? The upper one is between pin and earth. Pin means what? This one is pin, right? Different color. This one is pin, right? This one is earth, right?
Yes.
So what is this capacitance? C1 or C?
C1.
This is C1. So C1 should be at the top because they
Can you-
said, yeah, they said it first. That's why C1 should be at the top. And two, self capacitance. Self capacitance is C. So C1 by C, what is the value of C1 by C?
Yes. 8.
No, not that. C1 is C1. C1 actually, you can write KC, right? C1 is equal to KC, you can write
Yes, sir. Yes.
C.
Yes.
So they actually told us to find out the value of K here. Understood? The ratio of capacitance between pin and earth to self. That means pin and earth means actually what? Pin and earth means C1 and self is C. So C1 divided by C is equal to K. So they actually told us to find out the K. Okay?
Yes.
Now how to find out? Let me give you one example. So you do not have to apply the KVL every time. No, you do not have to. We already know V1 is equal to 8 kilovolt, V2 is equal to 11 kilovolt. What is the formula of V2? Remember, this formula is for how many insulators? How many insulators?
3.
3.
3, sir.
That's why we can use it. If it was 4, we cannot use it. Okay. So V2 is 11, V1 is 8, 1 plus K. So 11 divided by 8 minus 1. So your value of K this one. Understand? So value will be 0.375. Now the line voltage, that means they told us to find out the total voltage. Now we have V1, we have V2. Now we need V3, right? V3 will be V1 into 1 plus 3K plus K square. Okay. So V1 is equal to 8, 1 plus 3K plus K square. 8 into, okay, you can actually directly write it. 1 plus 0.375 into 3 plus 0.375 square. 18.125. Okay? That is your V3. Now, what will be your What will be your V?
V1 plus
V will be V1 kilovolt. So 8, 11, 18.125, 37.125 kilovolt. But this is not the line voltage yet. They told us to find out the line voltage, right? Right? What is the line voltage?
Yes, sir. 2-3 times this value.
Yeah, root 3 times, right?
Yes,
If you multiply these with root 3, your value will be 64.3. Understand? Let's check our result.
yes, sir.
Let's check our result. So value of K is equal to what? With 0.375. That's okay. That's correct. Now let's find out the value of V2, V3. V3. Your V3 is 18.12. That's correct. Your V is equal to 37.12. That's correct. Your line voltage is equal to 64.28. That is also correct. Now find out the efficiency. The efficiency formula is V divided by 3 into V3, right? What is your V? V is 37.12. Okay? Divided by 3. What is your V3? V3 is 18.12. Understand? So if you put it, if you put this in your calculator, you will see your efficiency is 68%. Very, very bad. This efficiency is very, very bad. Okay? Do you know why? Do you know why this value is very, very bad? Because of the K. What is the K here? What is K? 0.375, right? I want you to understand this very carefully. Understand? I want you to understand this very carefully. That is, your K is 0.375 and your efficiency is 68%. Now, what about the previous method? Previous math? What was your K? 0.11, right? Now, what is your efficiency? What was your efficiency? 85%. So, understand this. If the value of K is very small, your efficiency is bigger. If the K is very big, your efficiency is smaller. Understand?
Yes, sir.
Okay. I'm going to give 1 minute of break because Azan is going on. Okay. Okay, then so you got the point, right? So the value of K is directly dependent on the efficiency, or efficiency is directly dependent on value of K. If the value of K is bigger, your efficiency is smaller. That means that is bad. If the value of K is smaller, your efficiency is bigger, right? So how the value of K varies? What is K actually? K is actually the ratio of C1 and C, right?
Yes.
Now the value of C is constant. For a string, the value of C is constant. Now it should be smaller, right? This one should be smaller. Understand?
Yes, sir.
So how to make it smaller? You make the C1 smaller. Understand? If you make the value of C1 smaller, your value of K will be smaller and your efficiency will be bigger. Okay?
Yes.
Okay, you got the point. Now, how to make the C1 smaller? Okay, what is C1? C1 is this one, right? How can you make this one smaller? How? Remember, this is the capacitance formed between pin to tower, right? One way of reducing it is the increasing the distance between these two. If you increase the distance between these 2 points, what will happen? The air will be increased, right? If
Yes,
the
sir.
air is increased, that means the distance increases, that means the insulation increases, that means your C1 decreases. C1 decreases means K decreases. That means your efficiency what? Increases, right? So what you have to do, how can you increase the distance? You have to increase this distance, right?
Yes.
Understand? You
Yes,
have
sir.
to increase this distance. This is called, this one, see, the first method of improving efficiency. You told me, right, so how to improve the efficiency. Now you see, by using longer cross arm, that means you have to use bigger arms so that the distance increases. Understand?
Yes, sir.
See, the value of efficiency depends upon the value of K, the ratio of shunt capacitance and the mutual capacitance. The lesser the value of K, the greater the testing efficiency and more uniform the voltage distribution. The value of K can be decreased by reducing the shunt capacitance, that means C1. If you reduce the C1, the value of K will be reduced, so the efficiency will increase. Understand? So you have to use a longer cross arm. Now there is a problem of using longer cross arm. What is the problem? Can anyone say? Do not see it. Just use your common sense.
Sir, again.
There is a problem of increasing the longer cross arm. That means the distance. If you increase the distance, your efficiency increases. But one problem arises. What is that?
Sir, air gap increase.
Yeah, which one?
Air gap, sir.
No, air gap increases. I know that. That is not a problem. The problem is somewhere else. Anyone? Anyone?
Sir, stress.
The cost increases. The cost,
Yes.
because
Cost.
these are all steel tower. If you increase the length, the weight increases, right?
Yes, sir.
Weight increases means you have to use more steel. More steel means more cost. Understood?
Yes, sir.
Okay, so that is a problem. Now let's do not see this. We have already seen the first one. Let's see the second and third later. Okay, after the math.
Okay.
Okay, I'm going to give you one assignment, not assignment, a home task right now. Right now, everyone, do not see the book. Please do not see the book. Just see the screen and solve the math. Okay, you have 5 minutes of time. Please solve the math.
Google account. Google.
Okay, sir.
Okay, can you do that?
Yes, sir.
Yes,
Please
sir.
do it. Please do it. I'm going to pause the recording. Okay, you got it? Hello? You got that?
Sir,
Not yet?
sir, 1 minute, sir.
Okay, 1 minute.